Okay, now we're going to move on to the product and the quotient rule. And let's state the two terms. This means the derivative. Here's a new notation. This means take the derivative of what's to follow. If you have a product, and basically the theorem should state the following. If f of x and g of x are both differentiable, then the derivative is as follows. We will call this theorem 1. Since we're multiplying, this will be the product rule. Basically, you write down the two functions 2 times. The plus in the middle. First, you take the derivative of the first function, and the second factor, you take the derivative of the second factor. First term, take the derivative of the first factor, f of x. Second term, take the derivative of the second factor, the g prime of x. And theorem number 2 says that the derivative of f of x over g of x, the derivative of that is as follows. Now it amazes me how some people who teach this and some authors would write the numerator differently than what the rule states for the product rule, because then you have to memorize 2 completely different rules. The numerator is pretty much exactly the same as the denominator, as a product rule. The derivative is pretty much exactly the same. Exception being, there's a minus in the middle. And you have to divide by whatever the denominator is squared. There it is. Okay, you have to know these 2 rules. I call f of x the first and g of x the second. I like to say it's the derivative of the first times the second plus the first times the derivative of the second. Quotient rule is similar. Instead of saying first and second, I say top and bottom, or numerator and denominator. The derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. For example, if somebody told you that f of x is 3x squared minus 5 times 2x minus 8. Now you could multiply this out, get a nice polynomial, take the derivative like we did last section. Or you could use the product rule. I like to call this the first and this the second. So let's write it out in long form. Basically, you write down the problem 2 times. 3x squared minus 5 times 2x minus 8 with the plus sign in the middle. As though that was calculus, writing down the formula, you should say f times x. We didn't really do anything, and nothing very hard. I just wrote this down 2 times with a plus in the middle. Pure memorization. Okay. And you take the derivative of the first, and the first factor. Factors are separated by addition and subtraction symbols. These are the 2 factors. I meant to say terms. Those are the 2 terms. The first term is made up of 2 factors. take the derivative first. The second term is made up of two factors. Factors are things that are being multiplied. Take the derivative of the second. So now, okay, so what I've done so far was just write down the formula. Now I take the derivative of a polynomial. The derivative of 6x squared minus 5 is 6x times 2x minus 8. Do not take the derivative. The formula says just write down f of x. I meant to say g of x. Doesn't say the derivative. Plus 3x squared minus 5, that's f of x, times the derivative of g, which is 2. That was the calculus. Taking derivatives of two simple polynomials, like 3x squared minus 5 and 2x minus 8. And what we get is distributing the 6x. We get 12x squared minus 48x, and it's plus. So you have 3x squared times 2, which is plus 6x squared, plus a negative 5, which is negative 5 times 2 is negative 10. More algebra. And then 12x squared plus 6x squared, that's 18x squared. Don't forget to take away 48x, and do not forget to take away the 10. There's your derivative. Suppose you were told that h of x is equal to 7x to the 4th minus 2x plus 1, and this is being multiplied by 3x cubed minus 4x plus 5. You want to find the derivative. Well, this is the first factor, that's the second factor. The derivative says take the derivative, the product rule says take the derivative of the first factor. 4 times 7 is 28. Make the new power of x 1 less than 4, which is 3. Minus the derivative of a number times x is just a number. It's 2. Derivative of 1 is 0. So it's the derivative of the first times the second. The second is whatever the second is. It's not the derivative of the second, it's just the second. Then it's plus the first. 7x to the 4th minus 2x plus 1 times the derivative of the second, which is 9x squared minus 4. And the calculus is done. We just took derivatives of polynomials, and we wrote the formula down correctly. Okay, I'll leave it to you to do the algebra. That is, distribute the 28x cubed, then distribute the negative 2, and then add on this mess. Then distribute the 1. Right. So now, what if I give you a quotient? So before I do that, I want to point out, now that you've seen a product rule, I don't want you to be using the product rule on a problem like this. So I want you to use the product rule. The derivative is simply the constant times the derivative of this, which is 9x squared plus 1. Now to show you that the product rule lives up to that, let's use the product rule. This is the first, that's the second. The product rule says it's the derivative of the first, which is 0. Derivative of 7 is 0, times the second. Of course, that's 0. Plus times the derivative of the second, which is 18x. Now, the derivative of this is 9x squared plus 1, sorry. I was looking at the answer. It's 9x squared plus 1. So we get 0 plus 7 times 9x squared plus 1. But 0 plus anything is the anything. 7 times 9x squared plus 1. Okay, you don't need to do it that way. I did it in one line. Here to 3 lines, and it was much, much longer. In fact, we can even derive the constant multiple, multiple rule. If you have y is k times some function, it's times. You can use a product rule. Y prime is equal. It's the derivative of k times the second plus k times the derivative of f of x. If the derivative of k is 0 times f of x, that's 0, plus k, and the derivative of f of x is f prime of x. Well, this is 0. It's not there. It's 0. So like I'm saying, you get k times. Hit the product. It's her mess. Don't use the product. Now we'll do some quotient rule problems. What if f of x was equal to 3x cubed minus 2x squared plus 5x, just that. And we're dividing this by x. If this was the problem, I wouldn't use the quotient rule. I would do the division. Remember, this means 3x cubed over x minus 2x squared over x plus 5x over x. Whether you wrote that down or not, whether you write this down or not, you have to think it. You have to think, what is this? That is, what's this? The answer is, it's 3x squared minus, that's 2x, just like this was, plus 5. The x is canceled. Well, I can take the derivative of that. It's a nice simple polynomial. Answer is 6x minus 2. Bring the 2 in front. 2 times 3 is 6. Make the new power 1 less. 6x to the 1, which is just 6x minus 2. Now minus the derivative of 2x. The derivative of a number times x is just a number. That's why I took away 2. And although 5 doesn't equal 0, the derivative of 5 does. And if you add 0, you don't need 2. The answer is 6x minus 2. Don't use a quotient rule. And now if I change it ever so slightly, if instead of x I put x minus 1, that's the quotient rule problem. The quotient rule, other than that minus in the middle, is very similar to the product rule. It's the derivative of the top, which is 9x squared minus 4x plus 5. 3 times 3 is 9. Make the new power 1 less, which is 2. 9x squared. Minus 2 times 2 is 4. Make the new power 1 less, which is 1. 4x to the 1, or 4x. The derivative of a constant times x is the constant. The derivative of the top times the bottom, just the bottom, minus the top, just the top, times the derivative of the bottom. Remember, in front of the x is an understood 1. The derivative of 1x is just 1. Minus the derivative of 1 is 0. The derivative of that 1 is 0. 1 minus 0 is 1. And all of this gets divided by the bottom square. And the calculus is over. And all I did was take the derivative of the numerator at some point. That was the first thing I did. And then at some point I took the derivative of x minus 1, which was 1. And then I put the pieces together according to a calculus formula. And here's the answer. I mean, if you wanted to, maybe we can clean this up, maybe in that corner. 9x squared times x is 9x cubed. Minus 4x times x is minus 4x squared. Plus 5 times x is 5x. And then we multiply everything by minus 1. So we get minus 9x squared. You know what? Let me put it underneath the other x squared. Negative, so I just did 9x squared times negative 1. Negative 4x times negative 1 is plus 4x. And then positive 5 times negative 1 is minus 5. Minus 5. And then we take away 3x cubed, and we take away negative 2x squared. That is, we add 2x squared, and then we take away 5x. By the way, multiplying by 1 didn't do much. And then what we get is negative 12x cubed minus 11x squared plus 4x minus 5. That's the numerator. Okay, I'll put it all over here. Here is your final answer. And this, of course, is all over x minus 1 squared, just like it always was. 98% algebra. Now, like I mentioned before, if the denominator is a constant, you can use the constant rule. If I told you that f of x is equal to 4x to the 5th minus 2x squared plus 11 over 5. Well, the derivative is that constant. Remember, dividing by 5 is the same as multiplying by a 5th. So you have a constant times a function. The answer will be the constant times the derivative of the function. The derivative of the function is 20x to the 4th minus 4x. 5 times 4 is 20. 2 times 2 gave me the 4. Times the 5th. Times the constant. But multiplying by a 5th is the same as dividing by the reciprocal. I mean, after all, 1 times that is just that, and 5 in the bottom is 5 in the bottom. And there's your answer. You might want to factor out a 4x. 4x times, or 4 times 5 is 20. X times x cubed gives me x to the 4th. 20x to the 4th. Minus 4x times 1 gives me 4x. And this is all over 5. So you don't want to use the quotient rule. Let's clean up the original problem. And let's try using the quotient rule. I want you to see how messy it is, so hopefully you'll bother to learn not to use it. Okay, the quotient rule says take the derivative of the top, 20x to the 4th minus 4x, and then multiply this by the bottom. Minus the top, 4x to the 5th minus 2x squared plus 11 times the derivative of the bottom. The derivative of 5 is 0. This is not here. I'm multiplying by 0. And it's all over the bottom square. I'll kill off 1 5 on the top, and I'll kill off one of the 2 5s in the bottom. There's only 1 5 in the bottom. And what survives on top is 20x to the 4th minus 4x. And what survives on the bottom is 5. Other than factoring out the 4x, this is just what we got before. And if we factor out the 4x, we get exactly the same answer. There it is. So look at how much more work we did. We're multiplying by 0. We're reducing 5 over 5 squared, which is just 5 in the bottom. But that's all I got, not using the quotient rule. Don't use the quotient rule if the denominator is a constant. After next section, we'll talk about why you shouldn't use the quotient rule if the numerator is just a constant. Suppose I tell you that f of x is equal to 3x minus 4x to the 5th minus 11, and all of this is over x cubed minus 2. You want to find the derivative. Okay. The quotient rule says take the derivative of the top. That's the first thing you said. The derivative of a constant times x is just a constant. Minus, said minus. 5 times 4 is 20. Make a new power of x 1 less than 5, which is 4. Take away the derivative of 11, which is 0. Okay, so far I wrote the derivative of the top times the bottom. Minus. Now reverse this thing. Keep the top the same way. So now take the derivative of the bottom, which is just 3x squared. And then divide all of this. Other than that sign being in minus, all we've done so far is like the product rule. And you can't, but you have to put a minus in the middle. But then you can't forget that it's the denominator squared. And there's the answer. Okay, we'll try one more. For example, if somebody asks you to do this problem, what is the derivative of 3x minus 5 times 1 over 7x plus 4? First thing I would say is that multiply the numerators. 3x minus 5 times 1, of course, is 3x minus 5 over 7x plus 4. Now I have a nice quotient. Use the quotient rule. The quotient rule tells me, so now both the top and the bottom are polynomials. It's very simple to take the derivative of polynomials. The derivative of the top is just 3 times the bottom. So I took the derivative of the top, I did not take the derivative of the bottom. Minus. Now I reverse that. I don't take the derivative of the bottom, that is, it stays the same, but I don't take the derivative of the top, it stays the same, but I do now take the derivative of the bottom, which is 7. And all of this gets divided by 7 at the bottom, 7x plus 4, all squared. And you should distribute this 3, and you'll get 21x. And when you distribute the 7, you'll get 21x, and you're subtracting. So that's 0. Now you have 12, and here you have negative 35, but you are subtracting now. So you're going to get 47 over 7 plus 4 squared. This number is just 47. 12 minus a negative 35 is the same as 12 plus 35, 47. Okay, that completes the product and the quotient rule. Know your formulas and practice your algebra.